All right, welcome back to another installment of Math with Medina. Today we're going to look at section 3.1 on solving two-step equations. You can solve a two-step equation by using two inverse operations. Remember that the goal does not change. We still want to isolate the variable to find its value. And that word isolate, it's really important when we hear that we know what it means. To isolate is to cause to be apart from others, or oftentimes you'll hear me say, get the variable alone. So let's really focus on how do we get the variable alone on each of these next few problems. So our first problem starting off today is 3x plus 6 equals 21. So our end goal is to get x all by itself. So first things first, I need to get this term right here all alone before I can really isolate the x. So in order to get that by itself, we're going to subtract the 6 from both sides. And remember when I say both sides, that our equation has a border right down the middle. Once I've subtracted that from both sides, what I'm left with on the left side is just 3x. And on the right side, 21 take away 6 leaves me with 15. And then now I can see that 3 and x are multiplying. So my inverse operation this time around would be division. So I'm going to divide by 3 on this side so that I'm able to cancel this out. And then I divide by 3 on this side as well, leaving me with a value of x equals 5. Now, don't forget that every time we find an answer, we need to make sure we do a proof. So there's my proof symbol. And we rewrite our original equation. 3x plus 6 equals 21. And then, just like we did with our single-step equations that we were working on in 2.5 and 2.6, after I've written down my original equation, I simply substitute in the value that I found. So this time around, we found that x equaled 5. So we substitute in 5. And then we follow the order of operations to evaluate our expression. So here, I have multiplication, and then I have addition. So we're going to multiply first. So this would equal a product of 15. Plus 6 equals 21. And then 15 plus 6 would give us 21 equals 21. And as always, we are very excited that we got the correct answer. All right, so again, the really big thing I want to focus on is just that we have to isolate that variable term before we can do any multiplying or dividing of the coefficient of 3. All right, let's look at another problem here. So this time around, very similarly, I need to isolate this variable term before I can go any further. So I'm going to draw my little line down the middle to separate my equation. And this time around, I'm going to add 11 to both sides. So we have 11 take away 2, or negative 2 plus 11 would leave me with a total of 9. And we keep our t over 3 unchanged. So now that we have our variable term isolated, we want to get rid of that 3. So we would do this by multiplying by 3 on both sides. 3's cancel out, leaves me with t on the right-hand side, and on the left-hand side, 3 times 9 would give me 27. Now, right here, normally if I read this from left to right, it would read 27 equals t. But really, t is more important to us, so we're going to use that commutative property of equality, and we're going to flip the location. So t is going to move to the left, 27's to the right, but if you notice, our values didn't actually change at all. It just changed the way we read it. So now we can read it the way we say it, t equals 27. All right, don't forget, we need to do a little proof. So we recopy our original problem, negative 2 equals t over 3 minus 11. And then we go through and we substitute in our value for t. And this time around, t is 27. And when I evaluate this, it's really important that we take a moment and focus on the order of operations. So I can see that here I have division going on, and here it's subtraction. So in the order of operations, we'd want to divide first. So we have our negative 2, keeping our equal signs nice and lined up here. 27 divided by 3 is 9, minus 11. Negative 2 equals, and 9 take away 11 would be negative 2. Sure enough, we're right again. All right. Let's go ahead and move on to our third example today. Our third example, negative 9b minus 4 equals 5. the first thing we'd want to do here, just like the previous two problems, is we really want to focus on isolating that variable term. And don't forget that that negative in front of the 9 is part of that term. So in order to do this, we are going to add 4 to both sides. And for those of us that continue to like having something to remind us to keep it separated, you're welcome to continue putting that dotted line, dividing your equation into a left side and a right side. So here we are. On the left-hand side of things, we're left with negative 9b equals, and 5 plus 4 equals 9. Remember that negative 4 and positive 4 make a 0, so they can cross out. You can even put a big 0 there if we wanted for fun. All right, next part of things. We have negative 9b equals 9. So for some of us, we get a little confused in here what's going on. So we see a negative sign and think maybe it's subtraction, but remember, a coefficient in front of a variable, that's multiplying. So what that's saying is we have negative 9, this whole thing, times b. So we want to get rid of that, so we're going to divide by negative 9. And we get b equals, and positive 9 divided by negative 9 would leave us with negative 1. And remember, if you have something in the numerator and denominator that matches, they cross out because they make a 1. All right, so here we are again. Want to double check that we did it correctly. So we're going to do our proof one last time. Our original equation, negative 9b minus 4 equals 5. And then we plug in our value for our new answer. And our answer was negative 1. Negative 9 times negative 1 would give me 9. Take away 4 equals 5. And remember, 9 take away 4 would leave me with 5 is equal to 5. Great. So there's a few examples on how this works. Really, the big kind of takeaway message from all of this is make sure that you isolate that variable term first. So I continued on all of these to isolate the term that had the variable first. On all three, you can see we isolated the 3x here. We isolated the t minus 3, or excuse me, t divided by 3 here. And we isolated the negative 9b here. All right, so one last thing. Let's work on a story problem. So I'm going to go ahead and pause the video here for a minute and have a quick read of the problem, and then we'll get started together. All right, so together let's take a look at this. If we read through it, you can see I'm going to go through and underline some of the big information we'd want to take away from this problem if we're working on this on a test or a quiz or on one of our activities in class. So as I read through, I can see the first thing that should jump out is that the total drum set cost $495. And that the music store told us that we could make a down payment, specifically a down payment of $150. And then lastly, the thing we want to pull out of this is this idea that says we're going to make 3 equal monthly payments. So now our goal is really to answer this question, which is, how much is each monthly payment? So what I would start out on this and do is I'd first start out and I'd go ahead and I would do a verbal model. So we're going to say that the cost of our drum set is going to be equal to our down payment. And down payment is just the money we pay at the start to say that we are going to complete the rest of the payments and that we want this item. So we have our down payment plus, and it is going to incorporate the number of months times our monthly payment. Okay, so let's put in the information we know. We know that the drum set costs $495. We know that our down payment was $150. Plus, we know that we are going to pay 3 equal payments. And the big question is, how much is each payment? So we're going to go ahead and put P for payment, because we don't really know that. That's what we're trying to identify. How much do I need to pay each month? All right, and from here, I can see that I have a constant is equal to a constant plus a variable term. So again, just like before, we'd want to isolate this variable term. And in order to do that, we would get rid of the 150. And just so no one at home is confused as you're watching this, I'm going to go ahead and I'm going to real quick erase these two highlights. You don't think there's any kind of division going on. All right, so we subtract 150 from both sides, and looks like I might run out of some space here. So let me make that a little smaller. All right, so left-hand side of things, 5 take away 0 is 5, 9 take away 5 is 4, 4 take away 1 is 3, equals 3 equal payments. And at this point, I want to divide by 3 to find my answer. So I'm going to get P equals, and for those of us that can't do that in our head, on the side here, we'll real quick do it together. 3 goes into 3 one time. Bring down our 4. 3 goes into 4 one time. Bring down our 5. 3 goes into 15 5 times. So we get 115. So we can make the statement then that the monthly payment is $115. All right, so I hope that this helped in getting you started on this idea of two-step equations. I look forward to seeing you in class tomorrow. Have a wonderful evening.